let's talk about reflections. We have a parent graph y equals f of x. I'm going to look at this graph down here, and I see that there are two other graphs, two transformations. The first one is a vertical reflection, so that's down here in that fourth quadrant. And what I see, that's this one up here. If we negate our function, if we negate f of x, then it ends up being a vertical reflection of that function across the x-axis, which makes total sense because f of x is our outputs. And if we do the opposite of the outputs, if they used to be positive, they'll be negative. If they used to be negative, they'll now be positive. So let's just get a couple points on my parent graph. And I'll use my endpoints. So I see that if I plug 2 in, I get 5 out. And if I plug 5 in, I get 2 out. All right, so then on my vertical reflection, or my reflection in the x-axis, let's look at that one. So that's going to be x and negative f of x. Same input, so let's put 2 in. Well, my output for f of x is 5, and if I negate that, I get negative 5. Put 5 in, negate. And my output for when I put 5 in is 2. Negate that, you get negative 2. Makes total sense that these are reflections in the x-axis. Okay, so that's this one here. And that is an outside transformation. All right, the other one is an inside transformation. And that one's actually over here in the second quadrant. So what happens now when I negate the input? Well, that ends up being a horizontal reflection across the y-axis. And again, this is an inside transformation. Now, this one's a little bit trickier to see. So I'm going to do my best to try and explain this. All right, so what happens when I take x, those same x's? Well, I'm only going to do one of those same x's, okay? And then what does this end up looking like? All right, so I take the input of 2. And then I plug it into f of negative x. So I'm taking the opposite input. So now it's f of negative 2. Well, f of negative 2, there wasn't on the original function. There was no input on that original function. The domain of this original function was restricted. Looks like it's between 2 and 5. Negative 2 was never in the domain of f of x. Okay, so this one's going to be undefined. This one's not going to work. So we got to get a little bit more tricky here. What can I plug in for x so that when I negate it, or take the opposite of it, I would actually have an output on the parent graph? That's right. You could do like negative 2. Because f of a negative 2 is really f of positive 2. Let's do that. And f of positive 2 ended up being 5. So now negative 2 comma 5 is a point on this graph, and it happens to be right here. So another point that I could plug in would be negative 5. Because f of negative 5 is the same as f of positive 5. And that's the same as 2. And that ends up being this point right here. Let's see. To clarify a little bit better, I'm actually going to leave, I'll leave this first one as g of x. So our red one's going to be g of x. Because they're all called like y or f of x, and I want different names. And the blue one, how about the blue one I call h of x? So instead of having g of x here, I'm going to call it h of x. Give them different names. Moving on. Reflections across the x and y axis. So the pre-image y equals f of x in figure 1-6a is this function, this quadratic, where they've restricted the domain. So that happens to be this function here. It's the black dotted function, happens to be f of x. And we have a restricted domain there. All right, for a, we are going to write an equation for the reflection of this function in the y-axis. All right, so let's look at this graph. So which one was the reflection in the y-axis? H of x, right? So for this one, we're going to write an equation reflected in the y-axis. Now, notice that the domain restriction did not stay the same. Notice that now your domain is in between x being -5 and x being -2. All right, so not only are we going to have to write a new equation, we're also going to have to write a new restricted domain. Okay, and I'll show you how to do that algebraically, but also you can look at the graph and do it visually. All right, so for A, the way that we're going to get h of x is by doing the opposite of every single input, right? F of -x. So h of x is going to be the same as f of -x. Every single input gets negated, or the opposite. All right, so we're going to have, instead of x squared, -x squared. Instead of -8x, -8 times -x. And then nothing changes with the 17. Now when I square a -x, I get x squared. The -8 and -x, I get positive 8x plus 17. All right, so for that one, all of our inputs were the opposite. So our opposite inputs. I plugged in those opposite inputs and I got my new function h of x. However, the domain does change. So the domain changes, and I'm going to show you how to do that. All right, so what we're going to do is we're going to take our original domain, but the input is the opposite, right? The input is now -x. Okay, but we're going to place it right into our old domain. And then we're going to solve that domain for x. So in other words, I'm going to divide everything by a negative. And what happens to an inequality when I divide by a negative? All the signs, all the inequality signs flip, right? Because everything becomes opposite of what it was. So we got -2, my less than or equal to becomes greater than or equal to. My -x becomes positive x. And my less than or equal to, greater than or equal to. And my 5 becomes -5. And now I'm going to write that in a better order that makes a little bit more sense to me. That -5 should be less than or equal to x, which is less than or equal to -2. And isn't that exactly the domain that we have right here? Isn't x in between -5 and -2? And I just did that algebraically in case you weren't given a graph. All right, so for B, now we're going to write an equation for the reflection of this function across the x-axis. That happens to be this, which is our g of x. All right, so what we do here now is we do the opposite outputs. So this one is opposite outputs. So for B, we're going to say g of x is the opposite of f of x. Okay, so all we do is for f of x, we just do a negative, or we do the opposite of the entire function. Distributing that negative, there is my g of x. Now the domain doesn't change on that one, the range does, but nobody's asking about that. Okay. Plot the pre-image and the two reflections on the same screen. Now I'm going to let you check that on your graphing calculator. When you do that, remember you're going to need to put in your domain restriction. For some reason on these functions, they decided to restrict the domain of the parent function, which also restricts the domain of g of x. And then we found out the new restricted domain for h of x. Okay, so when you put those into your graphing calculator, f of x, g of x, and h of x, each one, you should use Boolean variables to restrict your domain in an appropriate way. And they should match this graph here.